All right, let's see what we remember and what we don't remember from break. If we look at number 1, it says multiplying the polynomials, okay? And we have 3 different binomials that we need to multiply together. And so what we need to do is take 2 at a time and multiply them. So we can take the first 2 and multiply them and then multiply it by the last one. So let's do 2 at a time. So I'm going to multiply x plus 1 times x minus 3. So x plus 1 times x minus 3. Now, how do we multiply those 2 things? Do you guys remember? I can do it. There's really 2 ways. And so Alexis is saying, let's go ahead and try it this way. If I put them on top of each other, I can multiply it just like I learned how to do longhand multiplication back in elementary school. We can absolutely do that. Negative 3 times 1 is negative 3. Negative 3 times x is negative 3x. And then if I come over here, x times 1, remember I put it under here now, we have 1x plus, and then we have x times x is x squared. And then remember we just add them down. This is just the algorithm of what we did back in elementary school. Okay? You didn't do 21 times 13 and multiply those longhand in elementary school? You didn't do 3 times 1 is 3, 3 times 2 is 6, 1 times 1 is 1. You never did that in elementary school? That is the same thing as that, except for those have x's. It's exactly the same thing. Now, some of us are not comfortable with that algorithm. And so I've never showed that to you before.
How did you get the negative 3x?
I didn't get a negative 3x. Oh, here? Because negative 3 times x. You take this and multiply it, just like you do here. You take the 3 and multiply it times everything. It's the same thing. Now, I've never shown that to you because, well, that's not the only way to do it. It is definitely a way that works, though. The other way that we've talked about how to multiply is just to distribute everything, right? X times x is x squared. X times negative 3 is negative 3x. Remember, it's like FOIL, right? First, outer, inner, last. Then we have 1 times x is 1x. 1 times negative 3 is negative 3. Combine your like terms, just like we combined them over here. We have x squared minus 2x minus 3. Most of us are familiar with the left-hand side, correct? That's what we've been used to seeing. I'm fine with either way that you want to multiply, whatever you feel comfortable with. But since most of us did this, it's probably what we'll do. Now, I'm not finished yet, because how many have I multiplied? Just the 2. If you look at the original problem, how many things do I have to multiply? So I have to multiply the answer I just got by the last one, x plus 4. So I'm going to take this, change colors here. I'm going to take this and multiply it times, what was the factor again? X plus 4. Okay, so Travis, are you writing this down? X plus 4. Do you want to do it on top of each other like we did on the left hand, on the other side like Alexis said? Or do you want to distribute everything? Distribute everything? It doesn't matter to me. We can do it distributing everything. Let me go ahead and just erase what we have over here. So if we do it the distributing way, which is totally fine, you're just going to take the first number or the first term and multiply it times everything. What is x squared times x? X to the third. Good. And then what is x squared times 4? 4x. Good. And then we're going to take the next one. Negative 2 times x. Negative 2x squared. Negative 2x times 4. Negative 8x. Then we have to do the last one. Negative 3 times x and negative 3 times 4. Negative 3x, negative 12. I have lots of things I can combine. I need to do them all. Did I miss something here? Oh, that should be a squared, shouldn't it? I think that's the only mistake I made. Double check me. Is that the only mistake? I think so. So I have 2 things to combine here and 2 things to combine here. Remember, you're going to give your answer in simplest terms. So I have x cubed plus, how do I combine 4x squared minus 2x squared? Okay, so 4 and negative 2, right? And so what do you get? So you get 2x squared. And then what would negative 8x and negative 3x combined to be? Negative 11x, good. And then we have minus 12. And that is the final answer. But look how much work we had to get there. We had to do to get there. We had to take 2 at a time and get an answer. Then we had to take that answer and multiply it by the last factor, and then combine all their like terms.
Yeah.
A lot of work. Okay? But it's actually very methodical. You just got to make sure that, that's why I draw these little connectors.
What's that mean?
Just tells you what I'm combining or what I'm multiplying. X times X, X times -3. You want to make sure that you're not missing anything. You are distributing everything. You don't want to take that first term and miss anything. Everything has to multiply by everything else. And then you just look at combining your like terms. Okay? You will have to multiply. You have a test coming up, believe it or not. I think it's Friday.
Oh, Friday?
Yeah.
Kind of weird. Are you staying up today?
I am, and on Wednesday. Okay? Perfect. Because we have some stuff to catch up on. Okay? We have some things to do. We got to get caught up. So, multiplying is going to be on your test. Can you do it? I think you can. It's not hard. It's just a matter of being methodical and not missing anything. Okay? Now, the part that so many of us struggle with is factoring. So here are 2 factors I want us to look at, and then I want to also look at the one that I gave you that I graded for extra credit on your homework. Let's look at these 2. Remember, some of you had that flip book that we made for all the different types of factoring. That would be a good thing to have out and to use as a reference. If you have that, great. If you have it at home, bring it Wednesday. We can practice with it. But what kind of special factoring is number 2? You tell me. Perfect. Sum of perfect cubes. Very good. And how do I know that is what the pattern is? How do I know that? By looking at it. You're exactly right. What tells me? A binomial. Good. And the first term is x cubed. That's a hint. And then how do I check for 64? What do I do to check to make sure 64 is a perfect cube? Do you remember? On the calculator, you can check it. So if everyone go ahead and make sure we know and remember how to check it. On your calculator, where do I go? Well, oddly enough, it was on there. Where do I go to check to see if 64 is a perfect cube, if we're not sure? Go to math. Which one is the cube root? Option 4. And I'm going to take the cube root of 64. And it works, doesn't it? So let's see if we remember the pattern. And this is something you have to memorize, okay? So, oops. Here is the pattern. If you don't have it written down, you need to. I'm going to turn the lights down so you guys can see it a little bit. We have to decide what our A is and what our B is, okay? So this x cubed plus 64 is going to be this, that's that one that I just asked you to do. So let's rewrite it with A and B. So I have x cubed plus what cubed? What's B in our case with 64? 4, because I had a 4. So it's x cubed plus 4 cubed. So we know what our A and our B are. Yes, sir. Got that in these batteries? Just grab another one for today, and I'll change it when I have some time. Okay? Thank you for letting me know. Yeah, it does need some batteries. All right, so let's use our pattern. Remember, this formula up here is something I expect you guys to honestly just know. So let's see if we can remember what it is. The first is just A plus B. So what is that first factor going to be here? X plus 4. Excellent. Done. Now I have the second factor to deal with. Now I'm looking at this side, this pattern here. So what is A squared? So what am I going to write here? X squared. And then notice my sign here is a minus sign. And then it says A times B. So in our case, it's going to be X times 4. In other words, 4X. And then I have B squared, which is going to be 4 squared, which is 16. And that is the factoring. I cannot emphasize enough the importance of this step. So many of you want to go directly from here to here. The problem I have with that is if you miss the step I've highlighted in blue, then you really don't know what A and B are. And you end up getting really large numbers. You try to square 64 here. Remember that? That was a problem for some of us before break. So what I want us to do is I'm going to pause the recording. I want you to practice another one. Here is one, x cubed minus 125. Okay? I have the pattern right above it. I want you to tell me what A and B are. I want you to do exactly what I did over here. I want you to practice factoring that. So I agree with you. We have x cubed minus 5 cubed. Please don't skip that step. Skipping that step will wreak havoc on your formula. Then remember, the first formula is the little one, or the first factor is a little one, and the second factor is a lot longer. And again, this only works for perfect cube trinomials. I'm a liar. Some are difference of perfect cubes. A binomial where each of them are perfect cubes. So what is my first factor here? No. Close though. It's x minus 5. Okay, very good. So x minus 5. The first factor has the same sign as the original. Okay? Now, my second factor is just going to be x cubed plus something and plus something else, just because that's what the pattern tells me. The middle one is just going to be a times b, which is going to be what? 5x. Very good. And then the last one's going to be 25, 5 squared. Excellent. Good. And that's it. I believe the first couple that you guys had on your homework were these kinds of patterns. Is that correct? I believe they were. The sum and difference of cubes. Moody.
Shouldn't it be minus 5x or just
Plus. The minus is only here when you have a, so those are the signs. So you remember the sign differences. Okay? Good. All right. The last one I want to remind us of in terms of factoring was one of the ones I looked at for homework. So I'm looking at question 24 because that's the one I graded for extra credit on page 301. So if you don't have that or you do have that assignment, go ahead and get it out and let's look at this problem. And I told you I wanted you to factor it. Okay? Great. I can't factor it the way it looks right now. Why? Has to equal what first? 0. And it doesn't. So how do I get it to equal 0? I got to move some stuff around. Subtract the 12. Excellent. So I'm going to get it to equal 0. This is an equation where it's really asking us, is that an x or x squared? It's x squared. Okay. Sorry. X squared minus 12 equals 0. Okay. Do you see your mistake? I think you had 16 here. Yeah. Okay, good. This is from homework. This is the last problem on the homework. This is one that quite a few of you asked me. I forget what to do when it looks like this. Well, it's really, the pattern of this is called a quartic trinomial. It still has that same pattern that we did before. You're still going to look for two numbers that multiply to be negative 12 and add to be 4. Do we know what those numbers are? 6 and negative 2. Very good. So I know that in my factors, as long as my leading coefficient is 1, which it is here, I can go ahead and write positive 6 and negative 2. I don't have to rewrite the middle term or anything. Only time I have to rewrite the middle term is when I have a leading coefficient other than 1 here. What numbers go in the front, though? Normally, it's x and x. But in this case, it's going to be x squared in each of those, because I have the x to the 4th and x squared. And that's it. That's the answer. Done. Okay? So the question I have for you, let's look at all the ones that I have factored. I have this one. This is a little bit harder to look at. The other ones are a little easier. This one. I have this one. What do these factors have to do with, that's only factors I've done. So what do these factors have to do with the graph at all? What does this factor have to do with graphing? Can everyone do me a favor and plug x to the 3rd plus 64 into your calculator? Graph it. Graph x cubed plus 64. What does that graph look like? What does the factor have to do with it? First of all, this is a cubic. Get off your phone for me, Timmy. Thank you. What does the end behavior of this look like? Do we remember? Are they opposite directions? Are they both up, both down? Do we remember any of this? It's odd. Degree is odd, so we know that the ends go our different directions. The leading coefficient's positive, so I know that the ends go like this. The left is down, the right is up. As x goes to negative infinity, y goes to negative infinity. But what does the factor have to do with the graph? So let's see if we can actually try to graph this thing. Really? I have to graph it. Let me go from back here and try it. What does your graph look like? It looks like a line. Well, it's hard to see all of it. I agree. It's definitely not a line. It's going to have some bumps and some turns. We probably are going to have to zoom out a little bit to see what's happening up there. But right now, let's just look at this part of the graph that we see. What in the world does the factors have to do with the graph? Look at the graph. Look at the factors. There's a relationship there. Okay. That has to do with the leading coefficient and the end behavior. I agree. What about the 0? What is the 0 or the root here? -4. If I'm not sure that it's -4, couldn't I go to, and I could calculate the 0? Remember how to do that? Second, calculate. We can go to 0. We can go to the left. Hang on, it's coming down here. We're going to see it in just a second. Oh, there it is, left. We'll go to the right. And we should get -4, and I do. I could also go to the table. And we'll see that -4 is a 0. What does -4 being a 0 and the factor have anything to do with one another? If you remember, if I take the factor and I set it equal to 0, aren't I going to get one of the solutions? So that factor tells me that -4 is a solution. Done. This other factor, how would I take it and what would I do to solve it? How do I solve that one? If I set this factor equal to 0, x squared minus 4x plus 16. X squared minus 4x plus 16 equals 0. How do I solve that? Well, if I plug -4 in, you're still going to get 0. I'm trying to solve it. You already know one of the solutions is -4, though. You're exactly right. But how do I solve to find the other ones? How many solutions are there total in this problem? No, there's 3. How do I know there's 3? Oh, I'm sorry, in this one there's 2. But in the original problem, this x cubed plus 64, how do I know there's 3 solutions? The degree is 3. I found one of them is -4. How many more do I need to find? 2 more. So here I'm going to find them. What do I do? Is it factorable? Is it? What are the factors? I don't think it's factorable, folks. It's not factorable. I know it's not factorable. How do I solve it? Factoring is only one way to solve. What's another way? X equals -b plus or minus the square root of b squared minus 4ac all over 2a. Quadratic formula. Guess what? I'm going to pause the recording. I want you to use the quadratic formula right now and tell me what the other 2 solutions are here. As a reminder, since you didn't like my singing, here is the quadratic formula. Figure out what your A, your B, your C are, and let's plug it in. So 4 is definitely one of the, I'm sorry, negative 4 is one of the solutions. It's what we call a real solution. We can see it on the graph. The graph showed us it crossed at negative 4. Now we're using the other factor to figure out what the other solutions are. So we have A, which is 1, we have B, which is negative 4, and we have C, which is 16. So negative minus a negative 4 is positive 4, plus or minus. B squared, don't forget to put your negative 4 in parentheses, minus 4AC. Whoa. All over 2 times 1. Why is x out where, baby? This is just x equals. That's just what the solutions are. So how do I simplify this? What do I need to do first? What's that D word? Do you guys remember? The discriminant. Good. The discriminant is what's underneath the square root. So I need to simplify that. What is negative 4 in parentheses squared minus 4 times 1 times 16? So if you do that off to the side, remember when your B is negative, it has to go in parentheses. What number is my discriminant? Negative 48. What does this tell me? When I have a negative underneath the square root, what kind of answers are they? Imaginary or complex? Those don't show up on the graph, okay? The only ones that show up on the graph are going to be the ones that are real. In other words, that negative 4 is the only solution that's going to show up. These two are imaginary. The graph actually looks something like this. Remember how we had that flattening out region? It crosses here at negative 4, and then it does something else over there. That's what the graph looks like. Okay? Now, we can simplify this. Do you guys remember how? How to simplify that? How do I simplify? Well, I know the I comes out, right? So we have 4 plus or minus I square root of 48 over 2. So far. Negative under the square root means I comes out. How do I simplify square root of 48, though? Is it a perfect square? No. So how do I do it? Square root of 48. What perfect squares go into it? Does 4 go into it? 4 is a perfect square. 4 times what? 4 times 12? Okay, is 12, doesn't 4 go into 12 too? 4 times 3 is 12. What's the square root of 4? 2. Square root of 4? 2. So what is 2 times 2? 4 radical 3. So this means this simplifies to 4 plus or minus 4I square root of 3 over 2. I'm still not finished. Good grief. Why not? I can still simplify it a little bit. What can I simplify? This, and this. What are they all divisible by? 2. So I want to divide them all by 2. So I'm going to have 2 plus or minus 2I radical 3. And it could be over 1, whatever. Those and negative 4 are my solutions. Shamar. We're just reducing the square root of 48. I'm just finding factors of 48. 4 times 12 is 48. 48. 4 times 12 is 48. So I have 1, 2. Sorry. So I just kept reducing until I got to the answer. Okay? I'm looking for perfect squares that go into 48. That's all. I could have started with 16. That would have been a lot quicker, but I didn't. So those are my solutions. If I ask you to solve a quadratic or solve any kind of polynomial, this is a way to do it. So let's try another one. I want us to give a couple to solve. We can either solve by factoring, or we can solve by what we call quadratic. Okay? So let's try that. Let's try another one to solve. Okay? Let me give you one to solve. You ready? Yes, you can. Let's try. Solve these. Let's try it. 8x cubed equals 1. Let's solve it. What do I do to solve? We're going to do a couple. This is the first one we're going to do, and we're going to do another one in a minute. How do I solve this? Equal it to 0. Always the first thing. Anytime you're asked to solve, get it equal 0 first. So write it down. Get it equal to 0. Once it's equal to 0, you're looking for a way to factor. Can I factor it? Is it possible? If I can, that makes life a lot easier for me. Is that factorable? Yes, it is. It is a difference of perfect cubes. Is 8 a perfect cube? 2 to the third power, yes. So in other words, 2x to the third power minus, is it 1 to the third also 1? So let's factor it. A and B. Go ahead and use what you know about your factoring. Do you know the pattern? And tell me what the factors are. Then we'll set each of those factors equal to 0 and solve. It looks like the majority of us went ahead and factored it correctly. The first factor is just 2x minus 1. The second factor is a squared, or 2x all squared. What's 2 squared? 4x squared. Don't forget that's a 4 now. Oh, I just erased something. How do I get rid of it? Go back. Don't erase. There we go. 4x squared. Now my signs are all plus plus here. 7 difference of cubes. It's using that formula that I had up on the board just about 15 minutes ago. That A and B formula. It's important to have that down. Then we have A times B, or 2x times 1, which is just 2x. Then we have B squared, or 1 squared, which is just 1. That's factored. Awesome. It's not solved, though. What do I have to do to solve it? Because that's what the directions say. The directions say solve. What do I need to do? What step, additional step do I need to take? Set them equal to 0. Each of them. The first one looks pretty easy to solve. Let's do that one. We have 2x minus 1 equals 0. How do I solve that? Well, what do I do to solve 2x minus 1 equals 0? How do I solve it? Add, subtract, multiply, divide. What do I do to both sides to get x alone? Add 1. When I add 1, I have 2x equals 1. Then what? Divide by 2. So x is equal to positive 1/2. That is one of my solutions. How could I check that? Could I graph it? Could I see if 1/2 is a solution? Go ahead, try it. Try 8x cubed minus 1. Make sure it crosses at 1/2. It better. Try it. It better. Absolutely 100% better. Otherwise, we did something wrong. So let's try it. 8x to the third minus 1. Oops. I hate when I do that. Minus 1. There we go. Uh-oh. My graph looks strange. What do I have to do to get my graph back to normal? Zoom what? Zoom standard. Zoom 6. Does it look like it crosses at 1/2? It does to me. Positive 1/2. Look at the graph. So, 0.5, which is what we wanted, right? How do I find the other ones? Does it look like it crosses anywhere else? So what does that tell me the answers are going to look like? They're going to have eyes. They're going to be imaginary. So I need to set this other factor equal to 0 to find the 2 complex solutions. Is that factorable? No. So how do I solve it? Quadratic formula, right? Go ahead, try it. Find the other solutions. Let me see what they are. So when we solve this, negative b plus or minus the square root of b squared minus 4ac all over 2a. When I simplify what's underneath the square root, what do I get? Negative what? Did y'all get an answer? Some of y'all got it. I saw it. Negative 12, yeah. Then how do I reduce that? Travis, how do I reduce the square root of negative 12? What do I do? Is there an I involved? How do I know there's an I involved, if there is one? Kimberly, is there an I involved? Watch. How do I know? Tell Travis, because he doesn't know. Because what, sweetheart? Because there's a negative under the square root. Anytime there's a negative under the square root, I know there's an I involved. Let's take that out now. And then the negative underneath the square root goes away. Can I reduce the square root of 12? Sure. The square root of 12 is just the square root of 4 times the square root of 3. The square root of 4 is just 2. So this reduces to negative 2 plus or minus 2i square root of 3 over 8. Still not done because, why? These can all be reduced by what? 2. So my final solution, negative 1 plus or minus I square root of 3 over 4. So the two things I have circled are my solutions. So what you need to pay attention to is the directions. If the directions say factor, I could have stopped right here, what I'm going to highlight in blue. Factoring is this part. The directions didn't say factor. The directions said what? Solve, which means I had to take those factors and set them equal to 0 to solve. How many of these solutions are going to show up on the graph? Only one. Because this one that I'm highlighting in yellow here, well, I was highlighting it in yellow. There we go. Is the only real one. So it's the only one that shows up. Over here, when you have i's involved, they don't show up on the graph. Okay? So here's what I'm going to have us do. Okay? I'm going to give you guys some problems. They're all going to be solving problems, which means you're going to have to use your factoring skills. You might have to use your quadratic formula skills, but we're going to solve these polynomials. Okay? And this is going to be your work for today. You have to write them down so I didn't have copies made, but no big deal. Okay? All right, so these are the odd problems on page 301. So in case you don't have them written down for whatever reason, you can always look at the textbook when you get home, but here they are. It does say solve, so your first step is going to be to factor them if it's factorable, and then you're going to set each of those factors equal to 0. So this is what your assignment is. Okay, we'll get to dividing on Wednesday. It looks like we're going to push our test back a little bit. I think we need to wake up our brain cells a little bit. It's been a while. Okay, so let's work on these solving problems for right now.